Hello friends, so today in this video we are going to discuss one more question which was asked in GATE 2007. So the question is, in a P plus N junction diode under reverse bias, the magnitude of the electric field is maximum at, and the options are A, the edge of the depletion region on the P side, B, the edge of the depletion region on N side, C, the P plus N junction, and D, the center of the depletion region on the N side. Okay friends, so to answer this question, first we need to understand some basic of PN junction and the electric field in a PN junction. Okay, so let me just draw a PN junction, right, in a 2D format. Okay, so yeah, so this is this is your P region and this is your N region, right? And here say you have your depletion region. So in P type, as we know that the majority carrier is hole, right? And in N type material the majority carrier is what? Electron. But in P type the minority carrier is electron. Similarly in N type the minority carrier is hole. So what happens is, when electron move from N region to P region, it recombine with the hole which are present near the junction, right? So it recombine with the hole, and as a result it form a immobile charge carrier, negative immobile charge carrier, and once it leave the N region, it leave a positive immobile charge carrier as well near this junction. So this is the plus plus plus, right? So this is the immobile charge carrier which are present in the depletion region. Okay, so let me consider, right? So this PN junction, this mid of the junction is, say x is here, x is equal to 0, right? And this direction I am considering as a positive direction, right? So this towards the N side, let me denote it as a xn, right? And towards P side, the depletion, the edge of the depletion region is xp. So as the direction of the P side is opposite, right? Because this side is positive, and this is the point where I'm considering this side is positive, so this side will be negative. So this is what? Minus x of p, right? So now we have x of n at the one side of the depletion region, that is towards N, and we have minus of xp at the P side, the P side edge of the depletion region, right? So now to understand the electric field in a PN junction, we need to know the electric field equation, or there are some important relationship for the electric field which are present in N side and the P side. So let me write it down, some important relation for the electric field. So for the P type, electric field is written as E is equal to minus E and A over epsilon x plus xp. So here I am considering, right? So here what I am doing is, here I am considering direction is from minus of xp, right? Direction is xp to 0. So direction is minus of xp, or I would say greater than minus of xp to 0. So till this point, right, where the depletion region is toward the N side, sorry, toward the P side. So this is the equation for the electric field, right? So let me consider it as equation number 1. Okay, so similarly for the n side, right? Similarly for the n side, so let me write it down. The equation of electric field would be E is equal to, right? So the equation of the equation would be E so the equation would be E is equal to minus E n d over epsilon xn minus x, and here the direction, right, is x tends to 0 to x of n. So here we are considering how much the depletion region is going from 0 to x of n, this direction, right? So x is greater than 0 but less than n equal to x of n. So this is the region, right? So now let me take a case 1, and let me consider the value of x is equal to minus of xp. So what I'm going to do is I'm going to put the value of x in equation number 1. So let me consider this as equation number 2. So this is equation number 2, right? So here what I'm doing is I'm putting the value of x is equal to minus of xp in equation 1, and I'm trying to find out the value of e. So when I put the value of x is equal to minus of xp, the value of e would be how much? 0, right? Now case 2, right? Again what I'm going to do is now I'm putting x is equal to 0 because the limit was minus of xp to 0. So now I'm putting the higher limit, that is 0. So now when I put the value x is equal to 0, the value of e would be how much? Minus e and a epsilon x of p. So this is the electric field when x is equal to 0, or I would say at this point x is equal to 0, the value of e is minus e n a epsilon, or sorry, minus e n a over epsilon dot x of p. Similarly toward this n side, let me consider case 1, right? Similarly here what I'm going to do is I'm going to put x is equal to 0 because it tends to 0 to x of n. So when x is equal to 0, the value of e would be how much? The value of e would be minus e n of n d over epsilon x of n, right? And case 2, when the value of x is how much? X of n. So once I put the value of x to x of n in equation 2, the value of e which I will get is 0. So what we got from these cases is when the value of x is equal to minus of xp and when the value of x is equal to x of n, that is basically edge of the depletion region, right? Either p side or n side, the electric field E is what? Electric field E is 0 in both the cases, right? But at x is equal to 0, here you could see, but x is equal to 0, we get E which is minus e n a over epsilon xp, and here minus e n d over epsilon n xn, right? So we get electric field at x is equal to 0. So let me plot the same thing, right, to get better understanding. So what I'm going to do is I'm going to choose another color for that one. So yeah, so I'm going to draw this thing. So okay, so this is the xn, and this is xp. This is xn and this is xp. This is y-axis is your electric field E, and x-axis is your depletion region x. So now, so what we know is electric field will occur only when there is immobile charge carrier, right? So what happens is outside the depletion region there is no immobile charge carrier, right? There's no charge carrier at all. So as a result, the electric field at this region, right, for N and P will be 0. So let me choose another color. So the electric field till this point would be 0. So electric field is 0 till the point, right, where there is no immobile charge carrier. Now what will be the value of electric field at the junction of depletion region toward N side and the P side? So here it is x of P and here it is x of N, and we have already calculated the value of x of N and minus x of P, and which is 0, right, which is 0. So at this point also the electric field would be 0. Okay, so now at x is equal to 0, so at x is equal to 0, we have find out the value of E is equal to this much. Okay, so let me say that this point is this value, right, minus E Na over epsilon xp, right, and in case of x of N, obviously the electric field or the value of electric field would be also at the same point. Why? Because suppose there is a point A and B and there is a voltage, say 5 volt, say some voltage is there, right? So if A to B the voltage is 5 volt, then B to A the voltage would also be 5 volt, right? You can't say that at same point, right, you would say A to B is 5 volt but B to A is 20 volt. It is not possible at all, right? It is not possible. So at same point x is equal to 0, this is x is equal to 0, right? At same point what happens is the electric field would be same. So this value and this value, right, will be, okay, let me just change the color. So this value and this value will be same. Okay, so now let me just connect the points like this, okay, right, like this, and this was the point where there is no electric field. Okay, so now here you can see that the electric field is in the negative direction. Why? Because here you can see that the electric field is always from N side to P side. E is always N side to P side. Why? Because it goes from, say, it goes from positive to negative side. So the electric field direction in a junction is from N side to P side. But here for the equation what we have considered is, you can see minus xp to 0 and 0 to xn. That means minus xp to 0 and 0 to xn. That means this direction, right? So the current which we have assumed is opposite in a direction to the electric field which occurs in PN junction, right? So that is the reason why the slope or that graph we are getting is opposite direction, right? So what we can do is we can just flip this overall graph to get the actual graph in the same direction when electric field is moving. So when we consider same direction, so at this situation you would get graph something like this, same graph, but I'm just flipping it out. So like this you will get, right? So like this you will get the graph for electric field and x. So now from this graph you could see that the electric field till this point is 0, till this point is also 0, and all of this point electric field is increasing gradually, but the maximum electric field which we are getting is at the junction, right? At this point the electric field is maximum, and this point is when x is equal to when x is equal to 0, right? Okay, so there is one more concept that we need to understand before answering this question. So this is for the p-n junction, right? So whatever we have calculated and whatever we have this draw the graph is for the p-n junction. So in p-n junction you could see that the doping, right? So in this p-n junction, right, so the doping is uniform, right? If there is a p and there is n, that means this doping is uniform. That is the reason why this graph is, and this slope is equal to both side, right? But what happen when we say p plus n as it is given in the question? So p plus n, that means p plus indicates the moderate doping, right? Or I would say the slightly more doping, right, as compared to n. So at this situation what would happen is, okay, so but in case of p plus n, right, so p plus, here plus indicate the moderate doping, and if there is a say p plus plus n, that means high doping, right? So we need to understand one important relationship between the depletion width and the doping, and which is the depletion width, or I would say that the doping concentration n is inversely proportional to the depletion width, say x. So as we increase the doping, the depletion width will reduce, and as we reduce the doping, the depletion width will increase, right? So in case of p plus n, so here p plus, right, so p plus means higher doping. So if there is higher doping here in p region, if n is higher, so as a result the depletion width will be what? Lower toward the p side, right, as compared to n side. So let me just draw the graph for the p plus n. So p plus n, this is for the p plus n, right? So I'm just drawing the p plus n. So this side is say p, this side is say n, right? So p plus n, so here p plus is highly doped, so that means the depletion width will be less. Say this is the depletion width, and n, which is less doped as compared to p plus, so this thing would be a little bit higher, so like this, right? So when there is a p plus n, or let me say in let me say that p n plus, just opposite. So at this situation what would happen is the graph would be something like this. Here n plus, that is doping is higher toward n side, so the width would be lesser toward the n side, and p side the diff would be a little bit higher because the doping is less. So you can see that in all the cases, right, in all the cases, let me just draw a simple pn that we have seen right now. In simple pn, because the doping is equal to both the side, so it would be same, right? So it would be same in both the side, the doping would be same in both the side. So here you could see that whether it is a p plus n or pn plus or pn, right, only the depletion width changes, right? Only the depletion width changes towards the less doped region, right, toward the less doped region. And if there is no changing, or there is no difference in the doping, the width of the p and n would be same, right, as you can see in p-n junction. But here you can see that irrespective of the doping, the maximum electric field always, see, the maximum electric field always lie at x is equal to what? At x is equal to 0. Okay, so irrespective of doping less or doping higher, the electric field is always at the x is equal to 0. So the answer of this question would be at the junction, right? Because at the edge of the depletion region, you could see this is the edge of the depletion region, and this is the edge of the depletion region towards n and p side, and both the side the electric field is 0, right? So the right answer for this question would be C. So let me go to the question again and just have a look. Okay, so the answer A, that was the edge of the depletion region on the p side. No, we have seen that the maximum electric field won't lie at the edge of the depletion region, either n side or p sides, and we have find out the electric field is always 0, whereas the maximum electric field we got is at the p-n junction. So the right answer for this question would be C.